Annyeonghaseyo and greetings, 8th graders from Bemidji, Minnesota. So today we are going to do a review. I know that we just did a review yesterday, but we're going to do a review again because as I'm looking at the writing assignments that some of you are handing in, I can see that many of you are still a little bit cloudy about the fossil record for mass extinctions and evidence of mass extinctions. So our objectives for today are to, one, I want you to be able to understand evidence for mass extinctions in the fossil records so that you can, number two, write an academic essay about the sixth mass extinction, the mass extinction that we're currently experiencing now. So in order to do this, you need to understand the different abnormalities in the fossil record. So let's go ahead and talk about what we're going to see in the fossil record, or actually what we won't see in the fossil record if something strange happens. So when we're looking at the fossil record, sometimes we'll end up seeing what amounts to empty spaces with no fossils, or maybe we'll see fossils of a certain creature appear again and again and again and again in the fossil record, but then in some area suddenly we won't find fossils of that creature, and in the higher levels we won't find it anymore. So we can assume that, oh, maybe this creature isn't living in this area anymore. And then if we look at the fossil record all around the world from similar strata and we don't discover those fossils there either, maybe we can conclude that, oh, this animal went extinct. And if that's the case with lots of animals, then we can conclude that there was a mass extinction. Here we have an image of different strata that we will see as an example in the fossil record, and so we see lots of different organisms in these lower strata, but as we go up higher, all of a sudden some of these complex organisms, the, I don't know, tooth-looking things disappear, the fern-looking things or the wavy hand-looking things disappear, and so we can say, hey, these things no longer live in this area, right? And if we find in the same layers all over the earth that these things are gone, we can conclude that they went extinct. And if lots of animals are going extinct at the same time, we can say, hey, it looks like there was a mass extinction. So this is evidence of a mass extinction in the fossil record. Now, here is just kind of an important piece of information. If we find volcanic ash in this red line, this sort of transition area where we're, first we had fossils of this thing and then after that we don't. If we find volcanic ash in that empty zone, then we can conclude, hey, probably there was a volcanic eruption which caused a mass extinction on Earth. Another example would be finding traces of meteoric rock in the empty zone, and again we can assume, hey, a meteor crashed in Earth, it threw dust into the air, including its own dust into the air, and that meteor crashing in Earth caused another mass extinction. If we are looking at the fossil record and suddenly in a temperate area, an area with 4 seasons, if suddenly we see palm trees, then we can conclude, hey, maybe there was global warming and that caused a mass extinction. So let's go ahead and talk about mass extinctions. I'm going to go over 3 mass extinctions today. 2 I already talked about. A third one will be new for you. Hopefully by talking about these different mass extinctions, you have a better idea of how to identify evidence of a mass extinction, talk about what you'd see in the fossil record, and then also make conclusions about mass extinctions based on this evidence. So mass extinctions. The first one I want to talk about is the Ordovician-Silurian extinction. And this one happened a long time ago, and almost all life in oceans died at this point in time. And 70% of all species died, which is an incredibly high number. It's like 70% of all living things were wiped out during this extinction. And they're finding evidence that at the same time, actually, they're finding evidence that shortly after this extinction happened, that there were a large number of glaciers that increased. And if the glaciers are increasing, then they're thinking, oh, the planet must be cooling off as well. However, before these glaciers appeared, we already had these extinctions happening. And so lots of scientists are trying to figure out what might have happened that would, one, cause mass extinctions, and then two, cause the Earth to cool down at the same time. And so many scientists thought probably it was a gamma ray burst, because what a gamma ray burst does is it destroys the ozone layer, which in turn lets lots of harmful ultraviolet light come into the Earth, and that ultraviolet light will kill living things. It doesn't kill them instantly, but over the span of a year or 2 years or 3 years, a very short period when we talk about geological terms, living things will start dying off. In addition to that, a gamma ray burst would destroy lots of our greenhouse gases, which kind of keep our planet warm. And so those are the two effects of a gamma ray burst, and those are the two things that we see in the fossil record, along with a disappearance of lots of living things that were formerly in a fossil record suddenly disappeared. And then we also have evidence of cooling that happens afterwards. So based on this evidence, we think a gamma ray burst destroyed life on Earth during the Ordovician-Silurian extinction. This is what the Earth looked like during this period, about 450 million years ago. And of course, we have a picture of our gamma ray burst, which is a supernova star which is spinning so fast it channels all of its explosive energy into two jets. And so one of those jets hit the Earth, destroyed its ozone layer, destroyed some of its greenhouse gases, and in turn destroyed life. So let's go on and talk about our next extinction event, which is the most recent extinction event and the most well understood extinction event. And this is the Cretaceous Tertiary extinction, or the KT extinction. And so not only did this wipe out all non-avian dinosaurs, but 75% of all species were wiped out, which is an even larger number than the Ordovician-Silurian extinction. So a tremendous number of animals were wiped out. This layer of rock is called the KT layer. So we can see two distinct set of strata. We've got a darker strata on the top, we've got a lighter one on the bottom, and in the middle we've got this white stuff. So that white stuff is called the KT boundary. And inside of the KT boundary, we will find iridium. And iridium, as I mentioned before, it's a very common element in outer space, but not so common here on Earth. And so, in addition to finding that iridium kind of at this lower level, when you look in the strata above the iridium strata, you find that there are 75% less species fossilized in the rock. And so scientists concluded, an asteroid or a comet must have hit Earth, and then all of these species disappeared. Therefore, we don't find them in the fossil record anymore. Here we have another picture of different strata of rock that have been exposed. It looks like maybe this is a road or a river, but nonetheless, you can see the KT boundary, this sort of black band that goes all the way across in this particular strata. As I mentioned before, they thought an asteroid or comet hit Earth, and this is where they think they've discovered the crater where the asteroid or comet hit, which is off the Yucatan Peninsula in Mexico. And this is an image of what it might have looked like when the asteroid or comet crashed into Earth. It would have created a tremendous explosion. That explosion would have vaporized all of the living things probably within that circle, or maybe even a larger space. But for the most part, what ended up happening was this collision cast all kinds of dirt and debris into the atmosphere, and that dirt and debris lasted in the atmosphere for years, which means there was much less sunlight, which meant plants died. Plants are the basis of so many different food chains on the Earth, which in turn caused a huge die-off of animals. So compared to the other two mass extinctions, this third mass extinction that we're going to talk about now is called the Great Dying. So those other two were big, but this was the really big one. This is the greatest mass extinction, the largest mass extinction that happened in Earth's history. I don't like using the word great because people usually think something that's great is wonderful. Anyways, the Great Dying, it was a tremendous, another not good word. It was a massive die-off of all living things. This is the Permian-Triassic extinction, which wiped out 96% of all ocean life and 70% of terrestrial life. So when scientists, of course, were looking at the fossil record, they noticed that all of these living things suddenly vanished from the fossil record. And they also noticed bits and pieces of volcanic ash in the fossil record. And so lots of scientists began to, I guess, search for a very large volcanic explosion that happened at the same time. And they did find one. They found something called the Siberian Traps. Now, Siberia is an area located north of Mongolia, kind of north of Manchuria. In this area, there was a tremendous I guess, volcanic event called the Siberian Traps. And this was an event in which magma or lava continuously flowed out of the ground for 1 million years. Okay, not a few years, it flowed out for 1 million years. And it buried an area as large as the United States, 1 mile deep in lava. So that's just an unfathomable amount of lava. So scientists originally thought that, excuse me, this event caused the Permian-Triassic extinction. However, later on, other scientists said, wait. This volcanic ash appears 300,000 years before all of these living things disappear. So it couldn't have caused it, could it? And so that sent scientists back to the drawing board again, and they began to search for more information about what might have happened. And what they found was that shortly before all of the animals died off, they discovered deposits of coal ash in the fossil record. Now, this is a really interesting discovery, and you know, it's also very relevant because right now we're experiencing probably the 6th mass extinction on Earth, and it is being caused by burning of fossil fuels like coal. And in turn, when we burn fossil fuels, we create carbon dioxide. Carbon dioxide creates global warming. Global warming and carbon dioxide in the air also causes ocean acidification. So there are some really germane parallels, some very important parallels between like what happened during this Permian-Triassic extinction and what's happening now on Earth. However, now we've got people to dig up coal and burn it, but scientists were wondering, oh, how was coal being burned way back then? And the answer, of course, is this lava flow coming from Siberia. So in addition to lava flowing above ground, lava was also flowing below ground. And this lava had worked its way into, I guess, different coal veins within Siberia. And those coal veins burned for thousands, if not tens of thousands or hundreds of thousands of years. And so this continuous burning of coal created lots of greenhouse gases. Those greenhouse gases in turn not only caused global warming, but carbon dioxide in the air, increased carbon dioxide in the air, caused ocean acidification, and this in turn killed over 96% of all ocean life. So this is a picture of some of the critters that were sort of swimming around in the oceans before the Great Dying. And this is an artist's depiction of the Siberian Traps, this continuous lava flow that went on for 1 million years and buried an area the size of the United States, a mile deep in lava. Hopefully this information will help you write your essay a little bit more effectively. Hopefully you have a better idea of where to go in terms of talking about our 6th mass extinction. Just to review, if you forgot, your job is to write about the 6th mass extinction, which is the current mass extinction that we're living through, as if you were someone who were viewing it 1 million years later, right? So I told some people, if you want to, just pretend like you're a scientist from 1 million years from now. You don't know what caused the 6th mass extinction, but you're looking at the fossil record and you're trying to find out what what information is in that fossil record. Someone else asked me what kind of criteria are you going to use to grade this essay, and basically I want you to give me 2 examples in terms of evidence and in terms of like fossils. So for example, we can see that for the Great Dying, we can see that ocean life began to die, and so that would be fossil evidence that there's no more fossils of certain types of ocean life. And then in addition to that, we can see that there is coal ash located in the same strata where these other creatures disappeared. And so that would be one example of evidence and fossils. So I want you to just give me 2 pieces of evidence, 2 pieces of fossil evidence as well, and that should be enough. As I mentioned before, if you have any questions, please hit me up at sjkwok@sejongacademy.org, or you can contact me during office hours every day, 9:30 to 10:30, or you can send me a message through Google Hangouts. Thank you and good night. Peace.